Hi, we're talking today with Dr. Eng Lim Goh. He's an HPC industry luminary of long standing, and his title is Vice President and Chief Technology Officer for HPC and AI at HPE.
Hi, Doug.
Hi, thank you for joining us today.
Thank you.
So one of the most interesting presentations I've heard this year was your talk at ISC in regard to this idea of data-centric computing. And I was hoping you could just give us a quick overview of your conception of data-centric computing, particularly this idea of the integration of HPC and HPDA and the implications that holds.
Yes. So HPC stands for High Performance Computing, HPDA, High Performance Data Analytics. Now on the HPC side, for decades, we've lived one way, and that is top-down. Meaning we use laws in physics to write and create our models, and then we send in the initial conditions to produce predictions. Right? And if there are no laws, we will write rules, like in the financial industry. That was how we lived all these decades in high-performance computing. But more recently, I've seen a change. That is, people looking at scientists, engineers, analysts, looking at alternative to that, and that is the bottom-up approach. And that is, you don't build your models. You start with past records, lots of it, to feed it into a machine learning algorithm, and let the algorithm evolve the model at the top. And after evolving that model, that is the training process, you can then use inference to do prediction. So the compute-intensive, data-generating top-down approach on the left, and the data-intensive, data consumption approach on the right. So top-down, bottoms-up, deductive, inductive.
So one of the themes you've discussed is that HPC in and of itself is a tremendous generator of data, and that's data that needs to be analyzed. If I have this right, then HPC, if HPC and HPDA are separated, you've really weakened the entire equation. But by bringing them together, you've got something new.
Absolutely, yeah. Because the data generator on the HPC side is producing data that needs to be analyzed. Because ultimately, the insight from the data, right, the discovery that's within the data is the key to why we are doing all this. So therefore, the HPDA side, where people are starting to apply more and more machine learning algorithm to go through that data, right, needs to be integrated with the HPC so that you don't have to move that data. So that's one, why we have to bring the two sides together. And secondly, as I've said before, because now people are also in the simulation side, the HPC side, where they are using two approaches, the top-down and bottom-up. This is where they're starting to look at bringing the two methods, top-down, bottom-up, together in a single application. And this is where you're right, integration of both sides gets more and more important. The compute side and the data side.
So part of the vision of these systems is really moving toward superhuman performance. In Frankfurt, I know you talked about looking at LINPACK as a classic benchmark. There will be a whole different benchmark for the systems of the future. It will be, can systems perform a task better than any human?
That's a great question. That includes, some philosophy in there, right? Yeah. In the bottom-up AI approach, right? Many of the methods in machine learning, the bottoms-up, where you consume lots of data and learn from it, they have evolved to a point where the benchmarks used by the industry, they are starting to beat humans. These benchmarks are mostly, for example, in the games, in the area of games, all the way from the early days of tic-tac-toe. If you're a computer science student, you'll be writing a machine learning algorithm or an expert system to try and have a machine play tic-tac-toe, all the way to checkers, and then a few decades ago beat the top checker player, to chess. We know about the Kasparov competition. beat the top chess player. And of course, most recently, AlphaGo beating one of the top humans in Go. The amazing thing about that is most recently, they not only got superhuman, right? By superhuman, we really mean beating the top Go player, one of the top Go players. They managed to get that machine to go through a reinforcement learning without data. Now that one gets you thinking. Without data, meaning all they did was to build a set of rules and got two machines to play each other and give them a reward system. And after enough somewhat random play with the reward system, it converges to an algorithm that is smart enough, right, to play against the top players. Now, what's next in terms of benchmark? You know, what would be the next frontier, right, in specific superhuman capability, right? Not general, specific. And this is where we work with Pittsburgh Supercomputing Center and Carnegie Mellon University, Professor San Hong, developed a poker system, right? Intelligence system. And then this is more complex in one sense because it is incomplete information. This is that next benchmark. Because
you don't know what your opponent is holding in his
precisely
hand.
because
Unlike a board game. Yes,
like in a board game, you see everything.
Right.
But in a card game, in this particular case, Texas heads up, no limit. Hold'em. Texas Hold'em heads up, no limit. Yeah. And they developed this, and in 2016, we went out to play against the 4 top poker players, so we lost. Yeah. Well, statistically, it was a tie, you know, but lost about 700K virtual money. Then the neat thing here is they went out, build the machine up 10 times bigger, faster, to go through the reinforcement learning again, came back early this year, beat the one of the top 4 poker players, $1.7 million, right? Yeah, and you can see how they scale their learning. They can scale, you see, and how fast they come back and be superhuman. But I must emphasize specific, you know, superhuman capability, playing, you know, checkers, chess, Go, and poker in this case, and specifically Texas Hold'em heads up, no limit.
Well, that's the classic hustle. You lose, and then you come back and win all the money you lost and everything your opponent has. So
yeah, and you start, and the thing starts to learn, right? As it plays the game, it learns what it is weak at. See, that's the thing, and it can sustain that attention span, right? Humans actually rested, of course, at night. They went to sleep, but the machine carried on figuring things out, you know, and then came back next day stronger, and next day stronger, and so on. Yeah.
And it has no fear, unlike humans.
Yeah. In fact, that's a very good point, Doug. You know, one of the top 4 poker players after the game, you know, commented on this, right? The last time you played the machine in 2016, where you all won, statistically tied, right? What was the weak thing about it? Oh, the answer was it didn't bluff very well. This year, when the machine won, what was the amazing thing? It bluffed really well.
Amazing,
you see,
amazing.
Yeah, that one makes you think. You know, comments from the humans, the top humans, right, telling you what they see of the machine. Yeah.
Well, one of my favorite quotes of the year was from the Go player who played AlphaGo last year. This year, just got wiped out by him, and he said this year that machine was the god of Go.
And it went through a blank slate reinforcement learning. That one actually makes you think here. And in fact, the Libratus, which is the poker bot that CMU built on the PSC machine, right, also went through the same thing, right? Reinforcement learning using 2 machines compete against each other, and all you give it are the rules of the game. And the second thing you give it is a reward system. If it wins, reinforces.
I think it's such an interesting point related to that is that by not teaching, training the system, you're not limiting it to human experience.
Yes.
It's going further afield.
So in a way, you could think it was almost alien, right? There was no human input other than the rules of the game. Yeah. I mean, imagine an alien came, right? And you just taught that alien, this is the rule of poker, right? And the alien will learn, right? In a different way from us, maybe. Right. And that's exactly what the machine did. Just a reward system and a rules. Yeah.
So this raises the other side of the equation, which is you were actually cited at Hyperion IDC's breakfast yesterday in regard to AI accountability, AI transparency. The point being that we don't really understand how humans think, so we really can't train computers to think the way we do. They think the way they do. And as AI systems move into really critical roles, such as AI-driven cars and medical treatment, where lives are at stake, how do we know how they make decisions? How do we promote AI accountability?
That's a great question, Doug. In fact, that has been in the minds of people in this field, right? Let me take a step back and give you some examples, right? First and foremost, the top-down approach has been the traditional HPC approach, and that's transparent. It is based on laws of physics.
HPC.
Right? Yeah, HPC, based on laws of physics, or based on experts coming in writing rules. It's all transparent, yeah, right? On the bottoms-up approach, right, where you consume data to evolve your model, some of the methods, like deep neural nets, right, deep artificial neural nets, by the time they go through their learning, a lot of times they give you a good prediction, but they can't tell you why. Example, when the AlphaGo, I believe when the AlphaGo competition was going on, and after the game, the human was asked, right? I believe it was Lee Sedol, but I'm not sure, right? Was asked, it was not Lee Sedol, it was the developer for AlphaGo, Hassabis, right? I believe it was written this way when he was interviewed after the game. Why did the machine make this fantastic move, right? That won the match, or something along those lines. Yeah, I'm just paraphrasing. And we know what the answer was. I don't really know.
Oh boy.
And that's the developer, right? And he has good reason to say that. Because those neural nets are so deep, so many layers deep, that it's so difficult to figure out how it arrived at that decision. Same thing with the Libratus poker board, right? Developers were asked, right? I believe it was Professor Sandholm was asked, so why did they make this particular bet, right? Yeah, that is so amazing, this bluff that was so amazing. The same thing, I don't really know, right? Yeah, because it's gone through reinforcement learning. It's just like, a teacher teaching grade 1 kids, right? After grade 1, you let the kids go out and play on their own for 3 years, and then they come back. The teacher don't quite know how the kids will develop. Reinforcement learning is something like that. You let the machine go on their own. You just give them the rules of the game and reward system, and they go off. And then when they are done, they come back. You don't quite know how they develop, right? Right. So that's exactly what's going on. So this is a problem for some of the industries that have regulatory requirements. Yeah. Like in the financial industry, like you asked, right? What do we do if there's no transparency? It makes a decision you don't quite know how, why. And this is where we believe the two has to come together, because the gold standard has still to be the top-down approach, law-based, rules-based, right? And then you can then have the bottoms-up approach that, because it is front-light, I'll come to that later, because it can make decisions after learning and training, at the back end, back heavy. It is front-light. It can make inferences very, very quickly. So that's why the financial industry like that. But then, in order to meet the requirements of the regulatory institutions, they have to go back to the gold standard, right? To get an explanation of why this decision is a good one. Yeah.
Well, yesterday it was I guess a commission in Germany Germany has passed a law, apparently the first national law about autonomous cars. That really imposes limits on and accountability on AI-driven cars around if, for example, the car is in control of itself when an accident occurs, then the car maker is liable. Another was that the run up to an accident is recorded like a black box in an airplane, and also that very interesting issue of if a car has to hit a baby or an older person in an accident, as an accident is taking place, what does it do? In this case, the German law stipulates that the car cannot be allowed to make that decision. I don't know how it answers that. But the point is that we are starting to impose limits, I guess, or accountability on AI.
Yeah, this is a question I prefer not to dwell into, right? Decision making. At this level. However, there's a lot of work going on to try and get more transparency into how the deep neural nets are making decisions. So there are papers just published recently, and then by deep neural net meaning you get these neurons connected to the next layer of neurons, up to 1,000 layers, right? And then by the time you send in your data and get the decision out at the other end, you don't quite know what's going on in between. So there is work going on, papers just published, to try and get more transparency into that decision-making process by meticulously tapping into each layer and getting the output in between to figure out and then reverse engineer, right? To reverse engineer back as to how ultimately that decision is made. It is laborious, right? But people are starting to believe it can be done, right? Using a computer to analyze the computer in this case. Maybe the analysis need to itself be a machine learning algorithm that's more transparent. Not all machine learning algorithms are opaque, right? Neural nets, especially deep ones, are difficult to make transparent, but people believe it can be eventually done. But if you're using classification like random forest or naive Bayes, they are more transparent.
Now, if we're moving towards superhuman AI machines, do you think a day will come when machines start moving toward human-like qualities of intuition and emotion? Is that so far out in the distant future it's not really worth discussing, or what are your feelings about that?
Yeah, that's the question that has been asked a lot. It concerns people, right? And there are many ways to look at this, right? One way is to look at timelines, right? Is it a year out, 10 years out, 100 years out, 1,000 years out or more, right? The further out you go, right, you start to have other worries. Let's put it this way, right? At the very, very extreme, right? Let's pick the most extreme out there. The closest star, supernova, right? I mean, yeah. Or if you pick even nearer, right? What if another great ape stepped out of the forest and signs to us and say, he or she would like rights, right? Rights to vote. In fact, in Argentina, I believe law was passed for one of their great ape to be treated, with certain rights. Yeah. So these are things people don't think about, and I believe is also partly why for AI, maybe some are not thinking it's that close, right? But so it depends. It's a timeline way of looking at it, right? Another way of looking at it is, will it ever emerge to be, generally intelligent first, right? Then sentient, yeah, and then self-aware, conscious. So generally intelligent, not specifically intelligent like today. Then I have to research this, but generally intelligent, sentient, then conscious, then self-aware. Some say it's philosophy. Some in philosophy say self-aware is when you know you are conscious, right? So it's the higher level. So at which level, right, will AI be? Maybe all the way up, but what timeline, right? But at the level of general intelligence, that will be the start of it. And this is where I got really interested in emergent properties. And this is where the scientific world has generally accepted this fact that there is emergent property. Like, for example, social sciences cannot be explained by psychology fully, Psychology cannot be fully explained by neuroscience. Neuroscience cannot be fully explained by biology. Biology not by chemistry. Chemistry not by physics. Right? Because at each level of complexity, something emerges when you combine them. So my thinking is, and in fact, there are Nobel laureates that have been talking about that. And in fact, this was from one of the Nobel laureates' explanation of emergent property. My thinking is, can you combine all the different artificial specific intelligence? If someone did that, a superhuman poker player bot, one that plays chess, one that drives cars, and combine all of them, 100 of them, 1,000 of them, and put them together on a system, combine, somehow fuse the neural nets, all the different AI methods, does something...
A learning machine.
Yes,
of
there's
that
something
scope.
new emerges, right? Based on the emergent property. That one has intrigued me, right? And if it does, will it be like human, right? Because reinforcement learning, as I say, is somewhat alien, right? Because it didn't learn from humans. It only received two things from humans: rules and reward system. Yeah. So when that emerges, general intelligence emerges, before sentience, consciousness, and self-awareness, right? Before that, it's where I'm now pondering more, because that's the first step, I believe.
Very interesting. Well, thank you for your thoughts, Dr. Goh, and for your time.
Yeah. You have great questions.
Thanks. Thank you.